Hello, I'm Philippe Robin, CEO and co-founder of Alysophil, a new company founded in 2018 in Strasbourg, and we are located in Strasbourg area. So Alysophil is acting in fine chemistry. We are developing new tools to produce and develop molecules for these markets. It's about two technological pillars. It's artificial intelligence and flow chemistry. Our aim is to reduce the time to market using artificial intelligence to generate new molecules, for example, and also new synthesis ways. And once the synthesis and the process is defined, we are aiming to produce with a kind of micro factory called ChemPocket within Alysophil field. And we serve markets like cosmetics, perfume, fragrance, defense as well. PIPAc Project is aiming to develop a new microfactory for active ingredient production. This is based on identification and selection of a molecule, a way to synthesize, the definition of a process, the construction of a process. But what will make a game changer is really to pilot this unit using artificial intelligence tool. And the goal and the action of Alysophil is really to develop this tool specifically for the PIPAc project, meaning that at the end of this project we will pilot the unit using an AI agent. So regarding the pathway to have the industrial demonstrator for PIPAc, we have different milestones. One of them in the early days was to select the molecules which will produce. And then it was to develop the synthesis using flow chemistry. This was already done for two selected molecules, active ingredient for Pharma. And in parallel, Alysophil has developed the piloting of the unit in virtual mode, meaning it's a numerical twin we did first, and that occurred in last summer. And the next step for Alysophil within this project was to develop the piloting in the real world. And this is what happened in December, meaning that for a specific molecule with our partner, Alysophil has developed an AI agent which piloted a microfactory in the laboratory. That's where we are for this day and in this project so far. The next goal of the project now is to mimic what we did in December for the other molecule we have in the project, and by the same time to build the lab demonstrator. So what we are going to do is to 3D print a reactor. We will connect the future reactor with a pumping, but also with the NMR, which is provided by Bruker. And by this, we will have another upgraded microfactory as lab demonstrator. And as it is built, by the same time, we are developing the artificial intelligence, which will pilot this second proof of concept. If we think about the advantage of our solution for the pharma world, there are different drivers of progress. The first is to have the possibility to produce more active ingredient in Europe. In addition, this new unit will be safer because the flow chemistry is known as using less volume of reactant at the same place. So if something is going wrong, the danger zone is much more smaller than batch. That's one thing. The second advantage is around environment, because we are aiming to use less solvent. The consumption of energy will be much less. And I would say these characteristics are more or less a characteristic for flow chemistry. What we are adding on top of this is the artificial intelligence, which will push forward the performance of such unit. When you produce a molecule through a process, what is very important is to have the quality of what you produce in real time. And once you have the pumping, the reactor, you need an analytical equipment at the end of the process to check if what you are doing is right. In the PIPAc project, we have decided to implement NMR from Bruker inline in order to collect the data from the reaction, and these data will be used to feed the artificial intelligence agent to elaborate the right rules and the right action to pilot the process.